So this is 1.6, and we're playing around with, does order matter? And if it does matter, specifically, when does it matter? When is it making a difference, or does it not matter at all? So this first one, we're dealing with sale prices. So imagine that you're making a purchase at a department store and you see that there's a 10% off sale. So 10% off of everything. And then you also have an online coupon for 5% off your purchase. So you're going to use both discounts. We want to see if the final price is affected by the order in which the discounts are applied. So if when you go to the cash register, if you're like, okay, I want to do this 10% off and then the 5% off, or do you save more money by going, okay, take the 5% off and then take the 10% off? Or does the order just totally not matter? So for this, I like to use actual real numbers to play around with it instead of these like philosophical, does it matter? It makes a lot more sense to me when I have like a real life example. So for this, we're going to pretend that, my pen died. Okay. We're going to pretend that we bought a $100 pair of shoes. Why did I choose $100? Because percents are out of 100, so the math is just really easy. I'm not going to do something that's $24.95. That's more difficult math. So I'm going to do a $100 pair of shoes so that the math is easier on myself. So first, we're going to apply the $10 off sale that the store has. So I'm going to multiply 100 by 1 minus 0.1. And what does that 0.1 mean? Well, that 0.1 is 10% off. So 1 is the price of the item minus 10%. And that'll give me 1 minus 0.1 is 0.9. So I'm at $90. So just with this 10% off coupon, my $100 pair of shoes are now $90. And then that $90, I'll apply the 5% coupon. So $90 minus 1.05. What's that 0.05? It's the 5% off. So then I do the math just like I did before. I can plug it right into Desmos as I see it. I don't actually have to do 1 minus 0.05 times 90. I can just type it all into my calculator at once. And now these $100 pair of shoes are $85.50. So I'm going to do the same thing. I'll use that same $100 pair of shoes, but this time I'm going to flip the order in which my discounts are applied. So I'll do the 5% off coupon. So $100 times 1 minus 0.05. The 0.05 is 5% off still. And that equals $95. And then we'll do the same thing now with the 10% off coupon or 10% off sale. So we'll use that $95 and take off the 10%. So then our final bill, just plugging it into a calculator, is also $85.50. So what does that mean? The final price is the same either way. The order does not matter because the multiplier is 0.95 times 0.9, which is just the 1 minus the 0.05 and the 1 minus 0.1. That's where I got those multipliers from. And they both either or the multiplication order doesn't matter. So the multiplier is 0.855, which when we multiplied that by 100, because I chose that nice easy number, was the $85.50. But it would work the same way if we bought a $20 pair of shoes or a $30 pair of shoes. That's the multiplier we would be using. So then part B, will applying the 10% discount and then the 5% discount result in a 15% discount. So can you go up to the counter and say, I have this 10% off and this 5% off coupon. So can I combine them to be a 15% discount? Explain why or why not. So for this one, no, you can't combine to 15% because then the final amount would be 80% of $100. So the 10 plus 15 is 20. The 10 plus the 5 is the 15%, which 100 minus 15% is 85%. So the total would be $85. And we got $85.50. So if you think about this as you have so if something's 50% off and you have like really great coupon for 50% off, you can't combine both of those 50% off coupons to get the item for free. Sadly, it doesn't work that way. So the second discount, the reason why is because the second discount is not applied to the $100. It's applied to the discounted amount. So first coupon was applied to the $100 and we got a new amount, $90. And then the second coupon is applied to that $90. Just like in this one, first coupon is applied to the $100, but the second coupon is applied to the $95. So the second amount is different. It's not taken off the $100. Okay, so that was pretty much the hardest one. The rest of this section is pretty easy. The next two problems that we'll do is dealing with the commutative property of addition and multiplication, which says that we can change the order in which we multiply or add numbers without changing the result. So we're commuting, which means to exchange or interchange two things. So you can look through the example there if you need to. So they're saying 3 times 4 is the same as 4 times 3, just like 9 plus 2 is the same as 2 plus 9. The order doesn't necessarily matter. So use the commutative property to rewrite each expression to make it easier. No, I'm reading the wrong directions. Use the commutative property to rewrite each expression and then combine the terms. So we have AB plus BA. Can we combine those together? So you have an apple and a banana, and your friend has a banana and an apple. Can we combine our apples and bananas together? Yes. An apple and a banana is the same thing as a banana and an apple. We can just change the order to be an apple and a banana. So we combine that together, and we have 2AB. We've got two sets of apples and bananas. Part B, hopefully this one pretty easy. We can rewrite the BA to be an AB. This time it's AB minus AB. So if I have an apple and a banana and I took away the apple banana, I'm left with nothing. And then the last one, I'm going to rewrite it so my terms are together. The like terms are together. So 3x minus 5x and then 4y plus 8y. It's just a little bit easier for me at least to add them because now I can go, okay, 3x minus 5x, well, that's negative 2x, 4y plus 8y, that's 12y. So a little bit easier when we group them together. So we know that 4 minus 11 and 11 minus 4 are not equivalent expressions, but sometimes we need to reverse the order of the numbers. So how do we reverse the order of the numbers so that they're both equivalent? Because in this one, the negative 11 is a large negative number versus minus 4. You're only subtracting 4 things out. Okay, so x plus 2, if we rewrote that, we flip the order. Nothing really changes. It's just 2 plus x. Next one, we have 4 minus 11, which we could rewrite as 4 plus negative 11. And then I can flip the order to be negative 11 plus 4. Those are equivalent. The negative is still attached to the 11. The 4 is still positive. We'll do the same thing for C, except now I have a variable instead of two numbers. So x minus 2 is the same thing as x plus negative 2. Rewrite the order -2 plus x. Negative is associated with a 2, a positive x. And then the last one, 2 minus x, we can rewrite to 2 plus negative x. Hopefully that wasn't anything shocking. We rewrite to negative x plus 2. So thrilling. Okay. Next one, the associative property of addition and multiplication says that we can change the grouping when we multiply or add 3 or more numbers without changing the result. So we're changing the grouping is the key word. So number 4, use the stated property to rewrite the computation to make it easier to compute mentally and then find the result. So here we have to do parentheses first, which is 13 plus 68. And I'm terrible at mental math. Like, I'd probably whip out my calculator for that one. But if I changed the grouping to be 17 plus 13, I can actually do that one in my head, which is going to be 30, and then I can add in the 68. 30 plus 68 I can do in my head as 98. The next one, 8 times 15. Again, definitely can't do that in my head. I could do 8 times 2 because I know that that's 16, but then I'd be left with 16 times 15, and I for sure can't do that. So let's see, if I did 15 times 2, that would give me 30. And then I can times that by 8, which is just 8 times 3, and then tack on a 0. So 240 would be my answer for that. Oh, I guess they're telling us what order to do things. Oops, I just definitely messed that one up. Oh well, we still got the same thing. So this one is telling us to add 72 plus 11, which I could definitely do in my head, but then to add the 19, it looks a little bit rough. So let's see, I'm going to change it to 19 plus 11 because that equals 30. And then I could add 72 to it. I can do that in my head as 102. And then the last one that we'll do together is adding or subtracting polynomials. We can use the commutative property to change the order, and then the associative property to rearrange the items. So let's see. They actually have us group the terms together. So we would rewrite the 5x to the 4th plus x to the 4th. I don't really want to do that because they really didn't give me a lot of room to rewrite it. So instead, I'm going to highlight the like terms, and that will be my grouping. And then I can combine like terms for my answer. So I'll add the yellow, and then I'll add the orange, and then I'll add the salmon color together to get my final answer. Do the same thing for B. I grouped the 7y squared by itself because I can't add it to anything. And then I have the 5y, the negative 8y, that can be grouped together, negative 14 and 3. There's my answer. And same thing for C. The only thing that I can combine together is those x squareds. Those are the only like terms that I have. So then I gave you a couple of homework problems to do. They're actually pretty easy, even though it looks like I gave you 5 of them, but they're pretty easy and they shouldn't take very long.